So this video will actually get used twice this week. So hi Algebra 1, hi Pre-Algebra if it's Friday, but for right now I want to use this time to review scientific notation. So scientific notation is used to represent really large or really small numbers. So I have 4 examples of each. So my first one are the really small numbers. So what I need to do is I need to figure out how to make this a decimal that is greater than 1. So it has to be greater than 1, but it has to be less than 10. So it has to be anywhere from like 1.0 all the way up to 9.9999, okay? It can only have the one number to the left of the decimal. So what we're going to do here is we are going to take this and we are going to move this 1, 2, 3, 4 spaces over. So I'm going to write this as 3.72 times 10. Now for this one, the really small numbers are negative exponents because I would have to take it back out 1, 2, 3, 4 spaces to make it back into its original number. So this is going to be to the -4th. Okay, and again, we're going to go here. I'm going to take this decimal and I'm going to move it 1, 2, 3 spaces. So I have 2. I don't have to put 2.0, but you can put 2.0 if you want. And it's going to be times 10. Remember, it started out as a really small number, so it's going to be to the 1, 2, 3, because I moved it 1, 2, 3 spaces. So to the -3rd. Again, if you want to do 2.0, you can write it like that as well. My next 2 problems, again, are still small ones. So I've got 1, 2 spaces that I moved this. So I ended up with 1.897 times 10 to the -2. Because remember, when I moved this back out, I would move the decimal to the left. And on a number line, the further to the left we go, the more negative or the more we are taking away. Okay, and then over here, I've got this, and I'm going to move it 1, 2, 3, 4, 5, 6. So I'm going to have 3.2 times 10 to the -6. Those are all my really small numbers. So if it has a negative sign, it means you're going to move it back out. So I would redo this one by simply putting 3.2, and then I'd take this and I'd say, oh, it's a -6, so I'm going to go to the left, 1, 2, 3, 4, 5, 6 spaces. Oop, I already have the 3. Don't draw the extra 0 there. Don't just put 6 zeros in front of it, because if you notice, I only have the 5 zeros in front of it. Here, if we were to do this, I wouldn't want to just do, so I would do 1.897, and I'd go 1, 2. I have to start at my decimal, and if you'll notice, I end up with the same thing. Okay, so the larger numbers get a little more difficult when you're taking them back out of scientific form. So we'll cover that when we get there. So here my decimal actually starts over all the way on the right. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8 decimal spaces over. And I would actually have to rewrite this whole number. I got a little carried away earlier when I was writing this. But it would be times 10 to the, what was that? 1, 2, 3, 4, 5, 6, 7, 8. So times 10 to the 8th. I got a little carried away earlier when I was writing these out. I got super excited and just put a ton of numbers. Okay, again, we're going to put the decimal all the way to the right, and we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is actually, again, going to be 2 times 10 to the 12th, or 2.0 times 10 to the 12th. Either of these work. It really depends. In most science applications, they will tell you 2 significant figures. Neither of you guys have done those yet. Well, yeah, no, neither of you guys have done those yet, at least with me. You may have done it in other science classes, but you have not done that yet with me. So just keep that in mind. They do mean the same thing. Okay, and then our last 2, 1, 2, 3, 4, 5, 6, 1.23 times 10 to the 6th. Now, how I would rewrite this back out is I would write this as 1.23. I would see it's to the 6th and it's positive, so I'm going to go to the right. 1, 2, 3, 4, 5, 6. And then fill in all my little hoops with zeros. Don't just tack 6 zeros onto the end of it and say you're done, because that's not what this means here. Okay, I'm going to start here. I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So 7.89 times 10 to the 8th. Again, we need to make sure that when we take these back out of scientific notation that we are starting at the decimal. 1, 2, 3, 4, 5, 6, 7, 8. If you are a little messy in your writing, you're going to want to take this slowly so that you don't draw, your hoops don't want to be like this and then a couple like that and then one like that and then start it back up and then get all confused. You want to make sure that you're kind of going even mine aren't perfect, but I can still tell where a dip is. Don't draw yours and be like, oh, here we go, that counts. Okay, just make sure you're doing it in a way where you can put the zeros in the little dips. Okay, and that's scientific notation.